probability distributions, the PDF, probability density functions, and other useful quantities. And then talk something about student random number generators. How can we generate student random numbers? And then I will explain very briefly on how to perform statistical analysis to the data. First, let's consider PDFs and CDFs for probability density functions and cumulative density functions, distribution functions. So about this one and in mathematical forms. And also introduce some of the commonly used distributions, such as Poisson distribution and normal distribution, real distribution. And then talk about how to solve probability problems, and then how to generate random numbers. The mathematical form of probability density function is usually given like this. And the function is always positive, non-negative, and the sum of the function equals to 1, which is normalized function. And the cumulative distribution function is defined like this. So if theta is a random variable, then the physical meaning of f of x means that it indicates the probability of the variable satisfy this relationship. So this is the definition and it's a physical interpretation of the function. And also the cumulative distribution function f is the monotonically increasing function satisfy this condition, which means the probability of a variable. So the commonly encountered distribution functions include the normal distribution and Poisson distribution, Rayleigh distribution, gamma chi-square, t-distribution, and others. And there are a group of functions in Matlab, and there is a statistics toolbox in Matlab where a lot of functions are supported. The function names have certain meanings. For instance, if you want to have a beta distribution, so the function name may contain beta PDF, beta CDF, and beta INV. I will explain this one later to you. And you can see that the function name consists of two parts. One is the name of distribution, the keywords. The other one could be PDF, CDF, INV, RNV, set, and fit. I will explain them by examples. PDF means probability density function. CDF means cumulative distribution function, as we explained the two concepts already. INV means the inverse of cumulative function, where you know the probability you have. If you know the probability equals to A, then the problem is how to find the value of X. So this is solved by INV, inverse probability problems. And RND is a random number generator. So if you find a suffix and RND, which means that you can use the function to generate a set of random numbers. And this one is for statistics analysis, which analyzes the mean and the variance of a certain signal. And this one is to find, fifth is to find the mean and variance or other properties of a certain detail. And there are several keywords like this, one for different distributions. So now let's consider normal distribution first, and the probability density function of normal distribution is described by this one. And mu is the mean in the distribution, and sigma is the variance of the distribution. This command can be used to find the probability density function if you select a certain point of x on the x-axis. With the use of function, you can find the probability density function to the same point. And you will draw the line, you will draw the point together, you will draw the probability density function of a certain kind of distribution. And this function can be used to draw the cumulative distribution function for normal distribution. And if you know mu and the sigma, the means and the variance, then you can draw the curve of x, of f. Now let's consider the case where we want to draw the probability density function for the combination of mu and sigma, like -1 to 1, 0 and 0.1. So these are the combinations of mu and sigma squares. Then what are the probability distribution, probability density functions and cumulative distribution functions? How can we do that? We have to select an x vector first, ranging from -5 to 5 with the increment of 0.02. And then we can specify the combinations of mu's and sigmas. And we can use the loop to draw the probability density functions and the cumulative density functions. And the result should be something like this. This one